In this fifth video, let's look at integrals involving inverse trig functions. So the thing to keep in mind here is to remember our derivatives, and in this case remembering that the derivative of arctangent of x with respect to x is 1 over 1 plus x squared. So now, looking at this problem, the arctangent of x squared over 1 plus x squared, we'll do a u substitution and we'll let u equal arctangent of x. Then du is going to be 1 over 1 plus x squared dx. So going over here to make our substitution, we'll have u squared in the numerator, and then what's remaining is 1 over 1 plus x squared times dx, which is actually identically equal to du. So this problem is the same as integrating u squared du, which applying the power rule backwards will be 1/3 u cubed plus a constant of integration, and then finally we back substitute, and instead of writing u, we will write arctangent of x. In the second example, we have a quotient involving two trigonometric functions, which will actually turn into a problem involving inverse trig functions. So first we make a u substitution, letting u equal cosine of x. Then du equals minus sine of x dx. So if we go over here and make our substitution, we will have 1 plus u squared in the denominator, and then what's remaining is 3 sine x dx. Well, the sine x dx we can replace with negative du. So if we make this substitution, we'll have minus 1 du, and then we have that factor of 3 there. So this is the same as integrating minus 3 times 1 over 1 plus u squared du, which we recognize as the antiderivative of the arctangent function. So this will be minus 3 times the arctangent of u plus a constant of integration, and then finally, back substituting, we'll have minus 3 times the arctangent of the cosine of x plus a constant of integration. Note that sometimes the notation for inverse tangent is either arctangent of x or inverse tangent of x. In this next problem, we're integrating a rational function, 3x plus 7 over x squared plus 1. So let's start out by trying a u substitution. Let's let u equal x squared plus 1. Then du will equal 2x dx. Now if we were to go over here to try to make our substitution, we'll see that we have u in the denominator. We can take care of the 3x dx, but we're going to have a problem expressing 7 in terms of u. So what we're going to do then, before we start, is to rewrite this as the integral of 3x over x squared plus 1 plus 7 over x squared plus 1 dx. So now this turns into two integration problems, namely the integral of 3x over x squared plus 1 dx and the integral of 7 over x squared plus 1 dx. Now to solve this first integral here, the u substitution that we originally did is helpful because now we can express the x squared plus 1 as u, leaving us in x dx, and x dx is 1/2 du, so we can replace the x dx with 1/2 du, and then we still have this factor of 3 in the numerator. The second integral is simply 7 times the arctangent of x plus a constant of integration. Now solving this first integral here, we will have 3/2 times the integral of 1 over u du, which will equal 3/2 times the natural log of the absolute value of u plus a constant of integration. And making our back substitution, we'll have ln of x squared plus 1 in absolute value plus our constant of integration. We can drop the absolute values here because x squared plus 1 will be positive, and we can also combine these two constants of integration. So our final answer will be 3/2 times the natural log of x squared plus 1 plus 7 times the arctangent of x plus some constant of integration. So this right here is our final answer.